Okay, my lovelies, I left you yesterday, or the last recording, with you filling in these sample problems. Okay, in this one, you added several vectors by lining them up, head to tail, and then you found the resultant vector from where you started to where you ended up. Okay, and you did that by, as you work through the vectors, you put the x and y values. When you add those x and y values, the numbers that you get for the sums are actually the sum or the length of the legs of the right triangle formed by your resultant. Okay, so what I just said, you drew a vector from here to where you ended up. You ended up with a vector, and if you had dropped down the imaginary y leg and brought the x leg over for that vector, these lengths of the legs are going to be what you got as the sums when you added up each vector. You are adding the vector. Okay, this first extension problem is very similar, and it's going to have you do the same thing. You will also have a couple of these in your extension problems, which I will assign right after this video. A student following directions on her treasure map starts at the origin. So it's going to be right here at the origin. Let's go ahead and put this up here. Give us some more room. So she went 18 meters north. So bring this down a little. We're going to bring a vector out of our toolbox. She went 18 meters north. You can see this one's clicked, this vector's clicked. It's 18. It's to the north so that the angle is 90 degrees. Your x is 0, and your y is 18. Your x and your y get filled into the chart. Then she went 5 meters west. So we're going to pull out another vector, put the tail on the head of the previous one. There, patience. Now you know what not to do. So she went 5 meters to the west. So I'm clicking on that one. It's 5 meters. She went to the west. So her total from the horizontal is 180. Notice that the x component is -5. You would put -5 right here, and you would put 0 for your y component because it's a horizontal line. Then she went 9 meters south. So we're going to bring another one out, attach it, and extend it to 9. So she went 9 meters. It's at -90 degrees because she started out on horizontal and she's come all the way around to 90, 180, now 270 or -90. So this all matches here for here. Over here for number 3, you would put a 0 here and you would put -9 here. I'm just following along with what it has up here. And then she went 17 meters east. So we bring out another one. Again, I remind you to use all the same color arrows. They will add up. It's just a quirk of the program. Okay, my last vector, 17 meters east, and she's at 0 degrees because it's a horizontal line. There is no angle from horizontal. So again, 17, 0 degrees. Right here for your x, you would put 17, and right here for your y, you put 0. Then you add this up. Here you had a -5, a 0, a +17. You do the math, you get +12. Here was 18, 0, -9, and 0. So if you do the math, 18 minus the 9, you should end up with a 9. And what that is going to tell us, if this is 12 and this is 9, that when we hit the sum button for the color or whichever arrow you used, the resultant drawn from where she started to where she ended, the magnitude is 15 because the legs are 12 and 9. This was 12, your x component was 12, it's 12. We did it correctly. Your y component was 9 when you added them. Sure enough, when you drop the imaginary legs from this resultant, or this vector, you get 9. So after the student had finished walking, what is her horizontal displacement? Your Vx sum was 12. Her horizontal displacement from here to here was 12. Her vertical displacement was 9. And again, you can do it graphically by drawing it out, and you have the 9 and the 12, or you can do it mathematically by adding all your x and y's, and it should give you the same thing. Using Pythagorean theorem and your answers from B and C, how far is she from the origin? What is the resultant? So Pythagorean theorem, if you plug in 12 for A and 9 for B, you should get 15. And then using the SOHCAHTOA, what is her direction? You would do this by doing your angle is equal to the inverse tangent of 9 over 12, opposite over adjacent. So this angle is what they're looking for. The angle would be inverse tangent 9 divided by 12. You could have just as easily using inverse sine 9 divided by 12, or you could use inverse cosine and go inverse cosine 12 divided by 15 for adjacent over hypotenuse. You could have used any of the three and you still would have gotten the same angle. Please understand that because in the extension questions, there are 10 of them. A couple of them are just like this. The next extension question here. A model airplane is flying north with the velocity of 15 meters per second. So you come over here, put your first vector, 15 meters per second. A strong wind is blowing east at 12 meters per second. So put your next one up, and it should be 12. Okay. Again, a model airplane is flying north with a velocity of 15 meters per second. That's this vector. A strong wind is blowing east at 12 meters per second. That is this one. Excuse me. So add the x components, add the y components, and it should give you You were to draw a line from the beginning to where it ends up, okay, and then drop the imaginary legs. When you add the two x's and you add the two y's of these two vectors, you should get 12 and 15. This program here is only to check your work. It is best that when you're given a problem to go ahead and draw it out, if nothing else, in the margin of your paper. Drop your imaginary legs, and it should give you 12 and 15. So what is the airplane's resultant speed? When we plug in 12 and 15 into Pythagorean's theorem, you should get an answer of 19.2. The heading is the direction. The direction. You can either use sine, cosine, or tangent in the inverse of any of those three to figure out what this angle is from horizontal. So it would be whatever degrees from horizontal. In this case, done correctly, you should get 51.3. If you're still having problems using sine, cosine, and tangent, please let me know, and I will set aside a time that I can meet with you on Zoom, and we will work through it. Now, the last part of your lab are the extension problems. I am going to attach these to the bottom below this lab sheet. This is what it's going to look like. Okay? There's graphing vectors. There's different scenarios. Here, this one is just you're solving for displacement. This one, you're solving for force. You solve it the exact same way. You're adding vectors. This one is velocity for the river. A boat is crossing straight across a river, and the water in the river is causing it to veer off to the right. Okay? Use the lab, use the PhET lab, use this to check your answers. On some of these, the numbers are going to be too great, but you can still gives you an idea. So these are not as laid out, but it's the exact same thing. You are adding vectors. You're plotting the vectors out, even if not to scale. When you find out what your final resultant, draw that out, drop your imaginary legs, and add your X's and add your Y's. It'll show you how tall or how long the legs of your right triangle are. Okay, hopefully this helps, and I look forward to seeing y'all back. Thank you.